3 looks at radioactive waste box, and obviously you're going to line that with lead, and lead is going to be obviously quite expensive. Right, so what you want to do there with that is you'll have to go through these questions. Now, everything we do in these questions is really about going through the steps and following these things. The questions lead you through. I want you to understand the concept of how these questions are set up for you. The idea is to try and make it so if you don't know how to do the previous part, you're not excluded from the rest of the question. So the first bit says, what is the inner length of the box? Well, you've got some information here that the base of the box has a ratio of 2:1. So in other words, if this box over here is in fact, if this box here is x, then we know that's got to be 2x over here. Got the idea? And we know it's got a height h. The next bit says, explain why x squared h equals 100. Well, you've got information. Now, these questions, the way they're set up, is they give you some information, and then what they do is they expect you to use that information to find one variable in terms of another variable. Alright, so in this case here, they give you the volume. So the big hint is of, flashing neon lights, that must be the thing that I have to equate to find h in terms of x. Alright, so over here, I'm going to show, well, I actually haven't shown exactly that. I've actually shown one step further. I've actually rearranged that for h equals 100 over x squared. Right, so that would be 100 is equal to x squared h. And what we will be wanting to do is say, therefore, h is equal to 100 over x squared. Right, now I could write an equation in terms of only x. Because every time I see h, I can substitute that in there. The next says, explain why the inner surface area of the box is given by that. Another word I might use for that is the word show. Show the area is given by that. So what you're doing there is saying, well, a box like that has got basically 3 different sides. The 3 different sides that we have are 2x by x by h, and 2x by h. So if you draw your 2D net, you don't have to draw your 2D net, but I know they are my sides, and I've got 2 of each of those. So I've got x times by 2x, x times by h, and 2x by h. So that's going to give me, when I times the 2 through, that's going to be 4x squared plus 2xh plus 2 times by 2. That's going to give me 4xh. You can combine these two things together. Now, we know that h is equal to 100 over x squared, so we substitute that into the equation. Cancel out that x with that x up here, and that leaves you with exactly what you're looking to find. Does that make sense? Going through that process? Now, the next bit of that question is going to say, use technology to help sketch the graph. Now, you might have really struggled with this concept right up to here. The word use technology means, don't really have to understand what I'm doing. Go put that in my calculator and graph it and find the graph. Right? So the only thing that's tricky about some of these is some of them are big sketches. Alright, so that's what I know I'm looking for my sketch of my curve for that. I know I'm going to be looking at something like whatever the value works out to be. In fact, that minimal point works out to be 5.31, and it's got a surface area 169.4. So when it asks you to sketch it, that's what you do, and you find the min value by doing it in the calculator. So if we put that into our calculator, I'll do that part for you. So go to a calculator, clear what you got in there. What have we got? 2x squared. 2x squared plus 600 divided by x. Now, we know we're looking for a min, so we know we're looking for the curve to curve downwards. Right, so when I graph that, I might not see what I'm actually looking for. This means my scale's out. So a quick way of doing that would be to go zoom. Now if you zoom down to, we used to do zoom 9 for stat fit, but if we go zoom 0, so you just type in 0, we'll scroll down there. it will find some part of that curve for you, can't we? Alright, so it will find some part of that curve for you. What I'm looking to do is maybe change that scale a little bit. Now, let's say we allow that for, well, let's go to maybe 20. Right, from there, and let's go from, say, minus 1, and we'll go up to, say, 300. And see if we can see our curve on there. Right, so have I done that right, that function? What did I do? I did 600 divided by 6, didn't I? What should it be? X. Okay, so I knew there was a problem in my graph. Now I'm looking to see, I now see my curve like that. Okay, so once I've got my curve like that, it's really easy to find the min by using your count button over here. We're looking for a minimum value. Right, go to the left hand side of that. You can either write in the value or do that. So I'm on the left hand side now, enter. To your right hand side, maybe it's something like 15. Okay, that's out there, that's okay. And so it will find your value. So really it's a matter of now reading this value off, 5.31, 1.69, 0.4. Okay, is my surface area, and that's the value of my x. Now going back to your question, right, so I've actually found that value there, and then it says draw a sketch of the optimum box. Okay, so I found those values. I know my x is 5.31. I know my minimal surface area is that. Now, really what it's asking you to do is draw a box and label the sides of the box. Well, x is this, 5.31. That's 2x, that's going to be 10.61. And then I have to work out what my h is. And I do that by simply going over here and putting 100 divided by 5.31 squared. And that gives me my h value. Got the idea? So that's really the same process for all of these questions.